Express numbers in scientific notation. So now we will be writing numbers in scientific notation. To write numbers in scientific notation, recall that they are written in n times 10 to the integer power. We must determine, so you need to recall this, and first determine n, and then the small n. So those are the two things you need to determine. So this is first, and then the n, and a power of 10, and a power of 10. That's the base. All right, so let's see, how do you work this out? So our first example in this one here will be, we'll start with the simplest ones and then we'll go to the more complicated ones. Consider that you have 2, 7, 0, 1, 2, 3, 1, 2, 3, that number. Even if we don't know how to read the number, don't worry about it. The whole idea is to get this number to scientific notation, right? So we will write the number as a product. So this number needs to be written as a product between 1 and 10 and a power of 10. Okay, so that's what we will do with this number. Why? Because the numbers in scientific notation have the form n times 10 to n power. That's the reason why we need to write it as a product, right? So our solution to this will be here. We look at this number here. We'll put we note that 2.7 lies between 1 and 10. Okay, I'm going to show you how we get a 2.7 in a little while. Just for right now, just bear with it. 2.7 lies between 1 and 10. Okay, to obtain this large number, the decimal point in 2.7, we must move the amount of places to the left in this case, right? So we move here. Here's the decimal. Remember, any whole number has a decimal point here. So we move. We go 1, 2, 3, 4, 5, 6, 7, 8. That's the new decimal point, and that's how we get 2.7. Now we got 2.7, which is for the letter n, times 10, because that's the amount of places that you move. How many times did you move? 1, 2, 3, 4, 5, 6, 7, 8. So it goes to a positive 8. So the power here is for the movements of the decimal point. This number is where it ended up. Okay, so 8 places to the left it moved, so we get positive 8. All right, now so if we were to take this and put now we say 2.7 times 10 to the 8 times, which means 10 times 10 times 10, 8 times, then times 2.7 is going to give us back the same number. So therefore this is how we write a number in scientific notation. But note that this value here in front of the decimal point, the one on the left hand side, this number here, cannot be, it must be between 1 and 10. All right, and then here could have as many decimal points as necessary, right? So let's go with another example. Now notice this was an example when we move to the left the decimal point to get this. So we're going to take now another number. We'll compare it with this one here likewise. Our other example will be, let me write this number here. To change the number to scientific notation, consider that we have 0.1. Okay, we have that number. You don't need to be able to read the number, all right? But the main thing here is for us to get this number here to scientific notation. Now, first we must write the number as a product. This product here, all right? The product of a number between 1 and 10 and a power of 10, which means the base 10, right? Now, numbers written in scientific notation have the form n times 10 to the n power. Our solution now will be as follows. Let's move the decimal point. Remember, the decimal point in this case is here. So it goes 1, 2, 3, 4, 5, 6. It moves 6 places so that we can get a number on the left hand side of the decimal. So our solution here will be 7.85 times 10. How many places it move? 6 places. But because you move your decimal point towards your right hand side, this now becomes -6 because it's on the decimal point section, right? 6 places to the right gives you a negative power. Moving to your left to become a smaller number, it gives you a positive power because you need to go back again. All right, so if we were to multiply this out now, okay, and we say 10 times 10 times 10 times 10, then that is going to give us to the 6 times, right, by a decimal times 7.85, it will give us the same value here again, right? In other words, look at this number. It became 7.85. There's only one value here on the left hand side of the decimal. There's only one value here on the left hand side, but this was a large number, looks small. This was a small number, looks bigger. All right, so we put the negative. So if you move the decimal points, if you have a standard number, two standard numbers here, and you get your standard number in scientific notation and you had to move to your left, the power is positive. If you have a standard number and it's a decimal and you convert it to scientific notation, it becomes negative because you move the decimal point to your right. Now, recall the laws of indices. When you have a base to a negative power, recall this rule. A base to a negative power is actually 1 over that base to the positive power. So therefore, we could accomplish back this number if we were to say 7.85 times, we put here 7.85 times 1 over 10 to the 6th power, or simply 7.85 times 10 to the -6. So we can write the number in scientific notation this form. This is the scientific notation, not this. This is, remember, the laws of indices here. You use this here, this one here, all right? So that's one of the rules. Let's try a few more examples like these. I'm going to try 1, 2 of these, and 2 of these, all right? So example 1. Consider that I give you now example, and I give you the problem 12,500. I want to express this in scientific notation. Write in scientific notation. So for me to write this in scientific notation, I must write it as a product of a number between 1 and 10 and a power of 10. The number in scientific notation have the form n times 10 to the n power. Remember that. Those are the things you need to remember. So therefore, when I write this in scientific notation, okay, and I want you to do this, I want you to show me that you are moving the decimal point. You move it from here, I put 1, 2, 3, 4. All right, so therefore I'm going to write it in red so that you can see the working. I have 1.25 times 10, 1, 2, 3, 4, the positive 4. That is in scientific notation. You have just moved the decimal points 1, 2, 3, 4, 4 places. Okay, try another example. In just changing to the scientific notation is not that difficult. So consider that I have now 585, okay, and I want to convert it to scientific notation. I move the decimal points 1, 2, 3, 4, 5. I move 5 places now, so it's 5.85 times 10 to the 5th power. Coincidence of this 555? Yes, coincidence, but you will not always get it 555 this way. All right. Let's try another example now. These were large numbers going to small, right? So I'm going to convert now a small number. So consider that we have there, right? And I want to convert this to scientific notation. So the way I need to convert this to scientific notation is that I need to move this decimal point for me to reach to the first number like this, the 7. So I go 1, 2, 3, 4, 5, 6, 7. Okay, coincidence again. So we put 7.85 times 10, but because you have to move to your right, it becomes negative 7 power. Negative if you move the decimal point to your right, positive if you move to your left. Okay, let's try our next example. Now, examples are endless. So if I have 0.125, I want that in scientific notation. Sometimes you may just move one decimal point and that's it. So that becomes 1.25 times 10 to a negative 1. In this case, you need to put the negative 1. You cannot be disregarding the negative sign, as in the laws of indices, where if it's positive you disregard the 1 and just leave it at 10. But this is a negative 1. Okay, so that is how we do that. So remember, this could be done using scientific calculators and so forth. Now, this was getting a number to scientific notation. All right, so now we're going to take some other number types that they look almost like scientific notation, but they are not scientific notation. So let me put this on the side, and the examples still continue converting to scientific notation. So this is example. What example was that? We have 1, 2, 3, 4, 5, 6. This will be example 7. Right? So if I tell you write in scientific notation, what is it that I want to write in scientific notation? Consider that I have 542.0 times 10 to the, say, 6 power. Now, because this may look, or you may feel that this is scientific notation, it is not. What does the rule say? Well, let's go back to its definition of scientific notation, right? This definition here. First, determine the n and then the small n and a power of 10. You must remember also that it is written as a product of a number between 1 and 10. This is not 1 and 10, this is more than 10. Okay? And an integer of 10. Well, that's an integer of 10. That is okay. Denote it by n. In the symbol scientific, n times 10 to an n power. So therefore, we need to move this decimal point from this number for it to become scientific notation. So this is not scientific notation. So what do I do? Well, I move my decimal points. Okay, so we will write this number as a product of a number between 1 and 10 and a power of 10. Why? Because this number in scientific notation have the form n times 10 to the n power. So our solution to this is as follows. So we start with the first piece, moving the decimal points. I have here 1, 2. It moved 2 places. So this movement that I'm doing right now is what I will write in red. This 10 to the 6th power, I will apply it afterwards. So just this movement, I'm going to have now 5.42 times 10. It moved to the left, so there must be positive 2. Do not consider this as a movement of a 0. Just go from here, 1, 2. So that's positive 2. Now, we have the number in this form now, and we need to recall the laws of indices that says if we have a base to a power times that base to a different power, we'll keep the base and simply add their powers. You need to recall this, right? So this is what we will be applying here. So now I have 5.42 times 10 to plus 6, which then gives me 5.42. 2 times 10 to the 8th power, and that's our solution. Now this is in scientific notation because this number here is between 1 and 10 compared to this one here. This is not scientific notation, this is scientific notation. So remember, this is scientific notation because we have it in the form of n times 10 to the small n power, and we all know what that means. Okay, so this is what you do here. All right, so let's do another one, but in this case we have the zeros to the left hand side. So I put right in scientific notation. So consider that I have the number 0.000528 times 10 to the negative 4 power. All right, consider that I have that number there, and I want to convert this to scientific notation. Well, it is not scientific notation yet, so I'm going to bring down the times 10 to the negative 4. Okay, and then I'm going to move my decimal point, that is 1 2 3 4. Stop it right there, no more. So put 5.28 times 10 to the negative 4. Coincidence, they are both negative 4s. Okay, so recall the law that says a base to a power times that base to a different power will keep the base and simply add their powers. So we do that, we put 5.28 times 10 to a negative 4 plus negative 4, which then gives me 5.28 times 10 to a negative 8. That is scientific notation. This is not scientific notation, this is scientific notation, this is not scientific notation. So you can convert this to scientific notation. Now remember, the powers may be positive, negative, and so forth. Just apply the laws of indices. All right, and you should be okay with that.